it to be an area of further review in the future. Also, an interesting thing is almost all the URI handlers are accessible via dbus calls if you're running an application, and many of them will accept parameters that are either undocumented or hidden in Palm's documentation. You can see them by reading the source code, and I can guarantee you that many of those are not validated, so I suggest reviewing those in the future. Now, everybody, when a new phone comes out, the race is like, how do we hack it? How do we get root? Well, for the Contra and Konami fans out there, Palm has made it really easy. You enter the Konami code, up, down, left, right, BA, start. If you actually, you have a friend over, it's BA, select start. You get 30 lives, and you're good to go. Once you've entered this code and enabled developer mode, you can plug in a USB cable, and you can get root access to the phone using freely downloadable utilities from Palm. One thing to note is if you have a device pin, you enable developer mode, then the pin will still ask you for it, but plug in a USB cable and your device is owned. This isn't really a security thing. I think it's just really cool that you can enter the Konami code and get complete access to the phone. Okay, so that's a background on WebOS architecture. And without further ado, I'd like to turn over to Townsend, and we can talk about how we approach finding bugs and some of the bugs that we found.
So, hello. As you can tell, Chris has done a lot of architectural analysis, and he'll actually go into some interesting bugs he found through that architectural analysis. I'm going to try and drive you through some of the stuff that we did to try to find some bugs, because that's what we do. So before starting down this path of trying to find bugs, we have to talk about attack surface. So what is the attack surface? Well, pretty much the attack surface for this phone is almost everything your desktop can do, and just like your desktop now, it's going to be wired 24/7. So we have a lot of things that we can attack in this particular phone. So we have email, SMS, various media player capabilities, instant messaging, file viewers, that kind of stuff. So what people target nowadays as basic things to go after or targets, you can do the same thing in this phone. And almost all of the things you can do on your desktop you can do here. The only thing we have here now is we have some SMS as well. The one thing I always like to point out is go on to the days where a phone was just a phone. Now a phone is your web browser. Now a phone is your music MP3 player. So it's really interesting how this is all panning out. The other thing we wanted to sit back and take a look at was what are the goals? So goals are always, for most bugs, I want memory corruption, right? That's sexy. That's what people want. I want remote root compromise. You don't always need memory corruption to get remote access. You can do some things, and we'll talk about later. We can do some neat injection attacks later that can give us access to the phone, the things that we want on the phone. So one of the things we sat down with was, effectively, since this is a hobby, and we're doing this part-time, memory corruption we knew would probably take a little bit longer. And the HTML injection is something new because we have both the binary side, and now we've got some interesting WebOS stuff on top of that. So you'll see us kind of talk about everything we wanted, but we sat down and the real goal was to get data. Since the phone itself is not amazing in storage and probably won't have amazing bandwidth, we're not worried about that side of it. So we would want to know, say, hey, listen, I target someone in the room, can I get all of your email? Can I get access to all of your email or your SMS? That kind of stuff. So that's kind of where we went with it. So this is a nice list. One thing this list shows is in a year, this is how many patches Palm has gone through. Most of this is probably because of us, but it has a lot to do with a lot of other updates that they have performed. The good thing is that they're very responsive. So I think Chris will attest to this as well, is we would release something and they'd be all over it. We have had time and time in with the head of Palm Security, and they have been nothing but wonderful for us. So it was really cool. But this is just a nice list showing how often they patched and kind of the bugs that we found and submitted to them. So I guess everyone wants to know is how do we test this thing? So the first thing we did is we looked at the attack surface, and the primary thing was, all right, what do we hit? What do we go after? What's the big exposed interface to the internet? Well, like everybody else, we went after web browsers, email, SMS, the media player, and even and file formats, because file formats are a pretty big target these days. So how do we do that? So we started with source diffing. All of these devices, they baseline upon release, and they say we're using this version and this version of code at this point in time. Well, what's nice is that Palm made this phone so open that it utilized. They have what's called a Palm open source portal where they give you the list of every piece of software that they use that's open source, and they give you every list of changes that they've made to that software. So if something was to come out, say tomorrow, WebKit gets owned, well, what version of WebKit is the phone using? Let's go back into a source diff. And this makes it very easy to go through all the code. Fuzzing. We fuzzed. We did a lot of fuzzing. We wrote some proprietary fuzzers. We utilized WebOS technology to fuzz itself, and we'll get into that in a few minutes. The other cool thing is that we talked about the source diff. So we have open source code, but this is all HTML, JavaScript, and CSS, and they don't obfuscate any of it. So if you wanted to see how it works, run the Konami code that Chris talked about earlier, log into the box, and check out all the code yourself. A lot of the analysis that was done on the architecture and even some bugs we found were based on the source code analysis. So source diffing. This is pretty simple. WebKit gets owned today. Does the Palm Pre WebOS suffer from the same bug? Go get the source. Go find out. It's pretty much that simple. The open source Palm's open source site is really nice in that it gives you that listing of all the open source software as well as the individual patches that were made. So it makes it very easy to go through and do the analysis. One thing we wanted to point out is this is not just a problem for this phone. This is a problem for, say, other phones and other embedded devices that have like long patch cycles or have to go through large amounts of quality assurance testing before patches can be released and that kind of stuff. So while it does affect WebOS, it's not just WebOS. So the way this started was me in a hotel room with a buddy having a beer. Like Chris said, I was doing this initially in a hotel room on travel from my previous job. And I was bored. And I was like, well, let me look at the phone because I just got it 5 days ago. So I generated a bunch of wide range of URL values, emailed them to myself because I didn't have a USB cable. I didn't have anything, any tools ready. And I did some really cool high-tech stuff called finger on screen testing. And I literally would do a binary search and click on a few links here and there. And literally within the first 3 minutes of this thing, the whole phone died. So, and this is actually a quick snapshot of, this is actually, so the phone also comes, one of the hardest problems about embedded devices and phones and getting access and debugging is that you usually don't have a debugger. GDB's here, 6.8, came natively, we don't have to install anything, it's already there for us to play with. So what's nice is this is actually a core file from this, clicking on this causes this core file. So obviously there's probably bigger problems. So now it's time to go back to the lab and start running some structured testing. So fuzzing round 2. One of the things I wanted to talk about is there's an open community for WebOS, and they're called WebOS internals. And they're a really cool bunch of guys in that they are just trying to make the application, write applications, make it better, make it the whole WebOS a community effort and that kind of stuff because Palm is very open about it. So what they did is they were nice enough to host all of the optware feeds, which would allow you to download pretty much anything on the phone you want. So apt-get, we're probably all familiar with Debian, and you just apt-get install, it's really add package-opt, but you would just be able to install whatever you want. So what we took the approach was, well, if I have the device, and I've got access through a shell to the device, say I just install SSH, why don't I just let the device fuzz? So we ended up writing some scripts that ended up fuzzing the device itself. And we just launch applications and monitor for core files. The beauty of Luna, that Chris had mentioned earlier, is that we can use Luna to fuzz Luna, right? So Luna has the cool ability such that Chris had talked about the application manager and how if you give it, say, a file, it'll take the extension or the file association and then launch the appropriate app. Well, that's great for us because I don't have to write a web server to bang off of. I don't have to do anything crazy. All I do is have to mutate the file if that's my choice, run it through here, fuzz it, see if it died. If it died, catch the core, see what the core says, rinse and repeat. And now I've got this self-sustained phone that I can walk around with during the day and have it fuzz as it goes. So I don't even have to do anything crazy.
Yeah, and the nice thing is that with Python or whatever installed on the device and the ability to launch the process, see if it's still running, check for core, like that's normally very difficult to do on an embedded device. And so here it's very straightforward testing. And so we were able to do, like the hardest part about testing is making your fuzzer reliable so that either it crashes or it hangs or whatever. Normally it's a pain in the butt for mobile fuzzing. But here, we can run several thousand iterations using Python on the device.
Right. And you could literally just be going for a jog and it's fuzzing itself.